Okay, this is the last module in the Introduction to Map Making R series, and this is going to go over interactive maps using the leaflet package. So interactive maps are ones that you can zoom in on, click on things and whatnot in like an HTML type portal or an R Shiny app. So this is the final module of this map making R series. If you have not gone over the other three modules of importing, exporting, projecting data, spatial data wrangling, and static map making, I would do those first before you jump into this one. All right. So I really like interactive maps. It's kind of a fun aspect, but they're not always practical. They're not going to be all that useful unless you're sharing information and making some sort of like website or something like that for collaborators. So we're going to primarily use the leaflet package to make interactive maps, but TMap can also make interactive maps. So TMap was the static map making package I used in that module. And what you do for TMap is just change the TMap mode to view to make an interactive map. So TMap mode view changes it to interactive. And this is a map that we had made in the TMap module. And this is how to make it interactive. So you can zoom in on it, which is kind of awesome. And it uses a base map. So you can look at like cities and stuff here. It doesn't really make anything else interactive. It does like have little pop-ups of like these habitats actually, which is interesting. It tells you the species and the habitat it was found in. What else this does is it has potentially layers you can look at. So we can click off Missouri streams or the border of Missouri, the Missouri streams, the fish, or we can click on different ones as well. Zoom in and out. What you'll notice on the bottom here is it says leaflet. Leaflet is the package. It is the program that was before or is separate from R that is used for this interactive type stuff. We can also zoom out and see where Missouri is for that map as well. So I think interactive maps are pretty cool for some applications, but not others. Okay, if you are not continuing from a previous module, please load in all of these map making packages, as well as the associated data that we would be using, which are the streams of the United States. And please filter that to Missouri, the states and territories of the United States, and we can filter that to Missouri. Fish locations, which are sampling locations of fish on the upper Mississippi River from the Long-Term Resource Monitoring Element Program. A raster data set, which we probably won't actually use because my computer does not like rasters, and the Missouri cities shape file, which are larger cities in Missouri. Again, this is the TMap interactive map mode that I just talked about using some of those data. All right, we're going to get into leaflet specifically though. So TMap and leaflet packages both use leaflet to make the maps interactive, which is why we see leaflet in the bottom right band of the map. Leaflet is separate from R and was created to make interactive maps from anywhere. So like most things, users of R have found a way to make leaflet compatible with R and create packages, thus making that leaflet package. Leaflet uses what are called tiles to make the maps interactive. The default is using tiles from OpenStreetMap, which is basically what Google Maps is. And you can zoom in and see labels like river names and county lines and whatever in the map. So if you are interested in more tutorials with Leaflet, I recommend this introduction here, which is just on the RStudio GitHub for Leaflet. I will note that any data used in Leaflet must be in the WGS84 projection. Therefore, you must reproject any data that are not in this projection before using it. Unlike TMAP that will automatically reproject your data, leaflet will not. So you will need to do that but first. So now that we understand the tidyverse packages like dplyr and the grammar of graphics using TMAP, leaflet is relatively straightforward because it reads just like the other tidyverse packages and even uses the pipe. So like the dplyr and other tidyverse things for wrangling your data that uses the pipe, but unlike ggplot2 and tmap that use the plus sign, we are using the pipe in between our lines of code here. But it's the same exact thing. So just between ggplot and tmap and dplyr, other tidyverse, and leaflet, interchange the plus sign and the pipe. All right, we're going to start with base maps and making a very, very simple base map. Leaflet uses base maps from Google Earth Engine and Google Maps to create the interactive maps. We start using Leaflet when we start with ggplot or tmap, just like that, by saying like ggplot, by saying tm shape. We're using the leaflet function, leaflet, which calls leaflet just like calling ggplot. It's not going to do anything though. Makes an empty map, just like in ggplot or tmap when no data are specified. So there's no map created because we haven't added any tiles to the map for reference or background. Tiles are what the base map is made of. So we need to add these tiles to the map, and you add new lines of code in leaflet using the pipe, unlike the plus sign for ggplot or tmap. OpenStreetMap tiles are used for the default, which was what we saw with the tmap view plot when we moved in and out, was OpenStreetMap. This is what Google Maps usually looks like. Use the function add tiles with no argument in parentheses to do the default. Right, this is what Google Maps pretty much looks like. OpenStreetMap, we can zoom in on these different countries. It's going to give you the country information in the native language. Keep zooming in. Know anything about China, really. All right, that is how you do this. Add a quick tile. Leaflet defaults to the entire world map, which was when we zoom in and out, we can see. There are many other open source base maps available for use in Leaflet as well. We'll see that with this providers function. All right, if we look at the names of providers, these are all of the open like source ones you can use. Some have limits on like how much you can zoom in and out or the extent of them. But otherwise, most of these are open source. There are like 233 of them, so there are plenty to choose from. So you can play around with which different base maps you want to use to see what works with your data. But you need a different function argument if you're going to use these provider ones other than the default. So it's leaflet, pipe, add provider tiles, providers, $sign. This is the Esri Nat Geo world map. So if you've ever gotten the Nat Geo magazine, this is what their world map looks like. Very familiar to me, at least. It's a very specific style. You can also select multiple tile cells on top of one another to layer them. So here we have the Nat Geo world map on the bottom. We're adding tiles, so add provider tiles. Again, providers, we're doing Stadia Stamen toner lines. We're adding this thing called options in here, where provider tile options, this is like a themes function in ggplot, or the layout function in tmap. We're saying opacity equals half, so just change the transparency. And then add another provider tile of Stadia Stamen toner labels. We'll see what this looks like. So here we did not have, or we have the like Nat Geo style like labels here. While here we have big ones, big black with a white outline on top of the Nat Geo ones. That's the stamen toner labels. And when we zoom in, we can see that for the countries as well. It still retains the ones from the base map, but we can also see that. And if we keep zooming in, map data not yet available. This is one of the provider tiles that does not zoom in all the way. But we can see that we have at least two different ones on here. We've got the Nat Geo and we've got the toner labels. The toner lines are like city lines and things like that, which zooming in doesn't seem like we have those data readily available from this tile provider. Account limit exceeded. There we go. That's because some of these aren't fully open access for this information. Okay. As another example of layering tiles, we've got the Stadia stamen toner labels here, right? I think this is the same. I don't know what I added here. Oh, you can add layers. Okay. I exited out of it, or I commented out. You can add layers control. Base groups equals these three. If we run that, argument map is missing. Oh, there we go. Make sure to pipe that. You can have the layers controlled. So what's nice about this is we can look at the layers and we can select which ones we're viewing. So the Stadia toner labels, the toner lines, and when we zoom in, it'll look different. If we just want the Esri map, we can have that highlighted. It's going to allow you to control those different base map tilings here by using this add layers control. Our base groups are these three. All right. So that's looking at some base map tiling, but you can actually do a lot, like you can do a lot more with this than just looking at fun tiles for this. You can add points directly to the map, and these points can come from multiple sources, including like a spatial points data frame or CSV files containing longitude and latitude columns. So we're going to practice with just 1 point first to see some of the things that we can do with it at a 1 point scale. So we're going to go back to the default leaflet add tiles. This is the default, but we're going to add a marker. We're going to make 1 point where the longitude is this, LNG, and lat is this. Add markers is that, and it adds this default blue marker. This is the St. Louis Arch at Gateway Arch National Park. So it's just adding a marker for that. We have a marker at the St. Louis Arch now. This is the default marker with the default open street base map. We can add different types of markers or just change it. So for a circle, instead of the little blue pop-up, it's add circle markers instead of just add marker. Long and lat stay the same. It's just changing the marker to be the default circle, which is just a light transparent center with a darker ring around it. And that is the default. This is still the St. Louis Arch. All right, the default. So make it open and blue, and we can change these settings for the default. So add circle marker, longitude and latitude are the same. Making it colors black. We're removing the stroke, so the thing around it. And we're making the fill opacity be half. So that's transparency, or what's called alpha in other packages like tmap and ggplot. So it is now black, half transparent, and it is just a circle. We can make this fill opacity be 1, and it'll be a black dot. Now we have a black dot there. It's just a way to alter these things. Okay. Ooh, I hate how team or one of the issues with like this in the viewer in R is that it like makes these weird black lines in here, so it's hard to see anything. It like covers up the data for some reason or your code, and I have never understood why. Okay. If you are curious about adding special markers or custom ones, you can look at the following code. We're not going to go into it that specifically though, but you can do things like add specific markers, which is called awesome markers. So here we're going to take one that's called icon1, where we're just naming an object called icon1. The function is awesome marker. The icon is named leaf on this website. We're going to make the marker color light gray, the icon color chartreuse, and we'll see what that looks like in a moment. And there are multiple libraries you can take these markers from. This one is Glyphicon, which you can look at the website specifically. See if I can pull that up. So what this looks like, or the three libraries you can really choose from are Font Awesome, here, Ion, and Glyphicon. And I pulled up Glyphicon. And this website has visual language that everybody understands, it says. And there's a bunch of different icons you can use. So if you want to click on one of these and you say, oh, I want this leaf. It is named Leaf. It gives you that number or that name right there. Dog, user, settings, car, user plus, user minus, etc. And you can find different graphics you might want to include in here. There's also like turtle, rabbit, cat, etc. So that's where this icon equals leaf came from, is I'm using the leaf one, and it came from the Glyphicon library. I want it to be chartreuse in color with a light gray background. So when we add this to leaflet, instead of add marker, it's add awesome markers. Lat and long are the same. We're saying icon equals this object we saved as icon1 here. What this looks like now is we have a light gray background on this marker and a chartreuse leaf. That's what we specified here. Icon color chartreuse, marker color, the background of the marker light gray. So this is just kind of a fun way to add more stylistic things to your leaflet map. Making your own icons too, using any image on the web saved on your computer. I'm not going to go through this. I've never done it. But refer to this leaflet tutorial if you want to add in your own image icons, which is kind of fun. One things you can do with these icons is make labels and pop-ups. So you can create labels on your map with the icon markers, and a pop-up will appear when you click on the marker. A label will appear when the cursor is on top of the marker. That's the difference between pop-up and label. Okay. Same thing with the add awesome marker. Icon equals 1. Now we're saying pop-up. What do we want in this pop-up? We want it to say St. Louis Arch. So we go to our map and we hover over it. Nothing happens. But if we click on it, it pops up with a St. Louis Arch label. And you can exit out that label. This is literally just one example of it, but if you have more data points or a whole list of them, you can add a bunch in here as well. So this is kind of a fun thing. When we click on that leaf marker, a pop-up window says St. Louis Arch. Now we can try a label instead of a pop-up. Or instead of pop-up here, it's just label. That's the only thing we changed in this code, label. So if we run this, we don't have to click on the marker, we just hover over it and it says St. Louis Arch. And then we can just keep going on. In the pop-up, once you click on it, it stays up until you exit out of it. Whereas the label is only when you hover over it does it show. You can also change the text size, font, shape, etc., and have the label always be present using the label options function. All of this is the same. Now we just have label options equal label options. We're not hiding text, so it's always going to be showing. The style, here we're listing things for the style. Color, and quotation mark equals pink. Font size equals 10 points. These are different ways of specifying themes and whatnot from like TMAP ggplot because it's using leaflet specifically, which is more specific to it rather than the tidyverse. But what this does is it always shows the label now, and the text is pink and the text is size 10 pixels. Make it 20 pixels. It's now larger, but still pink. So these are just things you can change in a list here for the style. You could do like font, family, and whatnot as well. So when we zoom in and out, it's always going to have that label because we made it do not hide that label. So if we zoom way out, it's going to just keep showing us the label right there. All right. So the label is always present in that interactive map. You can also remove the marker and only provide labels using add label only markers right there. Everything else is the same. But what this does is there's no marker, it's just the label. So we keep zooming out, it's just showing that label, none of the little marker with the leaf in it anymore. Okay, and you can add a lot more information to these labels. Maybe you want to add distances, population, etc. So here we're going back to the pop-up, so we have to click on it. All of this is the same, lat and long, we're adding tiles, we're adding the markers here. We're saying our pop-up, our information in it is we're pasting this text. We're pasting feature, we're breaking, we're pasting city, break, and distance. This would be, as an example, something that you might want to add. So like for this, we could say, put our feature here as St. Louis Arch. And it would have to be in quotation marks. Our city is St. Louis. And we could say our distance to something is like 100 kilometers or 100 miles to Carbondale, Illinois. So when you click on this marker, it's going to give you a lot of information on it now that we put in there. And obviously we like wrote in this information for this one point, but if you had something that was like feature city distance in a CSV file, it would copy and paste that information for the points if you had multiple points. But now it at least contains this information that we're interested in. And this again is just for one point, but we can do it a lot for more things. So next we're going to add our own data to the leaflet maps. So we've just been working on doing like this one point thing as an example. But we can add our own data as well. We just need to call the data like we did for TMAP and ggplot. So first we're going to add singular data types, and then we're going to add multiple data files into the same map. So for this first thing, we need to make sure our data are in WGS84. So let's look at the projection of our fish locations data set. It is in WGS84 right there. So we should be good to go. So within the leaflet function, specify our spatial points data frame, which is fish locations. We're going to add the generic default tiles, and we're going to add circle markers, which is the default blue. We don't have to put anything in here because it's just going to add those points which are spatial data points for the fish locations using the circle markers. So these are where all of our fish were collected from, right along the Mississippi River in 6 different areas and the Illinois River there. All right, we've added our own data. All we had to do was put in our data set. Cool. Next, we can change things about those circle markers. For example, we can change them global versus aesthetically, just like we can in Tmap and ggplot. So here we're going to alter the circle size by fish length, and we're going to add labels by species. So we're doing our fish locations, we're adding tiles, now we're adding circles. We're saying our radius or the size of our circle is based on fish length. There needs to be a tilde here. It's like kind of an equation for this. And our label here is by species. This is how we're changing things for each label and for our circle markers. So now if we zoom in, the radii of these default circles varies. And if we hover over the circles, it tells us what species it is. So this one, bluegill, this one, channel catfish, bullhead minnow, channel catfish, 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 freshwater drum, catfish. Labels, hover over them and they tell you what they are. We've changed them to vary by length. We could also do something like radius equals 1. And then that is a global thing. So all the points are the same size now. Aesthetically, we alter with the tilde and say by length to make them vary by the length of each fish. There's a cool way to do interactive map. You can zoom in on places and look at the species and their lengths. All right. Now we're going to add polygon spatial data to this leaflet map. So we just have points on here. We're going to use the Missouri Streams shapefile to add polylines to our map. So what this looks like is we're going to say add the Missouri Streams data. So instead of the fish data, add tiles, add polylines instead of add circles or add markers, add polylines. The streams are lines. This makes sense to add polylines. We're saying our color is going to be cornflower blue, and the weight of our line is 10. All right. They are cornflower blue, and they kind of look like weird squiggles. Keep zooming in, it's much easier to see the lines, but as we zoom out, it looks like solid blue. Change this weight. And it looks much thinner now as we're zoomed out. So this is a better weight for looking at our data. Potentially do 3, we can do whatever here, but it's gonna make the lines look different as we zoom in and out based on the weighting of those lines. So that's how you add a polyline. Add the tiles, add polylines, and it's gonna put all those lines in there. Cool. So now we're gonna add polygon instead of these polylines. Okay, I quick exited out of all the leaflets so we could actually see the code rather than it keep getting smaller and smaller in the window. All right, so we're gonna add polygons instead of polylines to this just to see how this changes. What we're gonna do is we're gonna take all these state outlines from where our fish data were collected from, which include Minnesota, Wisconsin, Michigan, Illinois, Iowa, and Missouri. These are the Midwest states associated with these data. So we're going to filter the states data set filtering name, including these. If you don't know how to filter, look at the spatial data wrangling module. And we're saving this as object Midwest. So now we're going to call that object in leaflet. We're naming it Midwest. Add our default tiles. Add polygons. We want the color, which is the outline, to be hot pink. Weight is the thickness of that outline or border. Fill color is filling in those polygons. We want that to be filled in with blue. We want the fill opacity to be 1. That's just transparency. Play around with that from 0 to 1. All right. We don't have anything showing up. We've got hot pink here. We should have states that are filled in with blue and have a hot pink outline. We've got this weird like hot pink outline up here, but that's it. Okay, why didn't this plot what we wanted? Let's check the CRS, or the Coordinate Reference System of Midwest. All right, it says World Geodetic System 1984. It should be projected in what we need it to be. But if we look at Proj CRS or projected CRS here, it says Popular Visualization CRS Mercator. This popular visualization is not something that can actually be mapped in leaflet. So if you have this popular visualization, it's a no-go. This needs to be projected into something that can actually be mapped in leaflet. So going back to the first module of this with projecting data, we just have to transform this. We're going to transform it to the streams dataset CRS because that is in a projectable WGS84. So it's the function stTransform, take our Midwest shapefile, and we're saying our CRS is the same as the CRS of the Missouri stream file. So this is going to reproject it, and now we can look at our CRS. GeoCRS, WGS84. This is now in the correct projection instead of the popular visualization one, which was unprojected actually. So we projected this to the correct Proj 4-string and projection here. So now we can actually map this. This is copy and pasted. Cool, this did what we told it to do. We wanted these 6 states filled in with blue and outlined in hot pink. Obviously, this is a horrendous figure, but it did what we wanted and actually like shows it because we now have it in the correct projection. So we successfully mapped these Midwest states. But we can add a little bit more information to them as well. So here we're going to add a highlight to the states we scroll over and a pop-up label with the name of the state. All right, same information here. Copied and pasted from before, but we're going to continue to alter these add polygons function. We're going to say add a label. Remember earlier that the labels in leaflet are this tilde followed by the variable. We want it to vary, or we want the label to be name. And labels are when you hover over something. We also want to highlight what we're hovering over. So highlight options equal highlight options. We're going to highlight it in yellow with a weight of 3. It's the same weight as the border that we made. And we want it to bring it to front. So we say true. We can see what that means in a moment. All right, we do have fill opacity as half instead of 1 here, so it's a more transparent. When we hover over the state, it becomes a yellow border. It brings it to the front. That yellow becomes the first thing you see, and it also provides that label. Here, Michigan, Wisconsin, Minnesota, Iowa, Illinois, Missouri. If we said bring to front false, it still highlights it, but because it wasn't the last polygon drawn, Illinois in the bottom corner is covering part of it, so it's still pink. It's not fully bringing it to front. Same with Wisconsin here. There's still pink along that border. Illinois was apparently drawn last there. Missouri, pink and yellow. It just brings the highlighting, it makes it pop to the front if you put true. So everything will be highlighted in yellow there. All right, don't run this code. But what about rasters in leaflet? So we've added points, we've added polygons, we've added polylines. Leaflet by default has a maximum raster size of 4 megabytes, which if anyone works with rasters, this is a very tiny raster. So I would just not use leaflet to map rasters. It can map them, but their megabytes limit is very small. I'd recommend a different avenue for raster mapping and we're not going to run this whole code because one, it would take forever to reproject the raster into WGS84, but it also would take forever to map this raster because it's a lot more than 4 megabytes. So for the raster, it has to be in WGS84 for leaflet. So reproject a raster, which takes forever because you have to recalculate these squares. Do not run this. But what you do is just say add raster image and whatever raster you want to put in there. Again, I would not recommend doing this, but if you need to, this is how you would do it. Okay, moving on from rasters. So now we have added single layers to these maps. The points, the polygons, the polylines. What about if we combined data layers? We want to add multiple data sets to the same map. What we do is we do not specify the data name in the leaflet function. We instead specify individual data file names in the respective add XX geometry function instead. All right. What we're going to do is simplify the stream data set. So it's the shapefile of all the streams for the polylines. We want the Mississippi River only. All right, now we have Mississippi River. We're going to just parse this down so it's easier. Our fish locations, we only want the Lagrange pool, LG. There's locations 2 there. All right, now we're going to make a leaflet map. Say leaflet. No data goes in this leaflet function if we're adding multiple data files. Add tiles, that's the default. Add polygons. Data equals Midwest 2. Those are our reprojected state polygons. We're saying our color for that border is black. Our weight is 3. The fill color is gray. Fill opacity at half. We're labeling them with the name of the state, and we're still highlighting them. We are going to bring that to front though, so we'll put true there. We're now going to add polylines of the stream of the Mississippi River. So data equals stream 2. We just made it. It's just the Mississippi River. Saying make the color of those lines cornflower blue and label it with the name of the river. Pipe, to add another layer. Add circles. Data, fish locations 2. Color, make those circles forest green and label the points by species. So what this does is we can zoom in and out here. We've got these states filled in with gray with black borders, and we can highlight them and find out their names by hovering over them. When we zoom in, we've got the Mississippi River labeled, and it is the entire Mississippi River, not just what's in the study system. And if we zoom into our green points, it's really hard to read what any of these points are because we put bring to front true. We put that as false because it's true we only